guess that's true. All right, so welcome everyone. It is Tuesday. It means another API review. Today we are doing apparently source generation for interop. So if you don't care about interop or source generation, I'm so sorry, but that's going to be the next 2 hours. So which one should we start with? This one or the other one? Sounds good.
This isn't intended to be a name nitpick. This is me asking for clarification. Go back to the API proposal for a second. The virtual method table, wherever that was, you scroll up. So that's in a fairly generic namespace, but it's specific to COM virtual method tables, right?
No, this works for any table of virtual function pointers. This is one of those types that was part of our generic virtual method table generator that is also needed by COM, so we put it as part of the COM proposal because we can't do the COM generator without it.
So this is really like this is just a POCO basically. You just give it the pointers and it gives you back the pointers, and we ensure they're laid out the way we expect them to be laid out.
Yeah. Basically, you can't do a value tuple of void star and void star star. So we made a named type for it.
Got it.
Yeah, initially we had talked about like doing a span, but then we had to pass the length around everywhere, and that was very unwieldy.
Sorry, I don't understand that. You had to pass the length in addition to a span?
Yeah, for virtual method table, we initially had a read-only span of int ptr there, but that ended up becoming very unwieldy because we had to pass the length everywhere to make sure we had a length, but it wasn't really worth doing all of that logic when we're still trusting the user on the length anyway.
I'm not understanding because there's no length here.
Yeah, we got rid of the concept of tracking length
So then,
because it wasn't worth the energy.
so
and
then,
the extra complexity.
how does that? But then your complaint about span was lack of. I'm confused. Your complaint about span was you had to pass the length, but you got rid of the length anyway. What was the?
Yeah, the idea was to have safety around like, oh, we make sure that the V table is 8 entries long. You don't try calling function 9 on the table.
Okay.
And then we realized that we were relying on the user for all the numbers anyway, so it doesn't matter. Basically,
You're saying that span, that the length span includes, was unnecessary overhead.
Yes. And it was adding significant amount of overhead to the design.
Because length check is just one thing. Like if you get the number wrong, you just call the wrong method with the wrong layout, and so bad things happen no matter what.
Yeah.
Yeah.
Yeah. So the idea of kind of the different pieces here is the object that represents what we used to call a runtime callable wrapper implements the IAM managed virtual method table provider interface, which for COM is just COM object. So COM object implements that interface. But that interface provides the only contract that's needed by the interfaces that can be iDynamic interface castable implementations. I don't know if anyone remembers that whole concept from when we got COM wrappers approved, because that was about the same time then.
Yeah, I don't want to drill down too quickly, but I'm curious. I'm trying to sort of form a mental model of who exactly we expect to be using these things, and therefore the usability we expect to come with them. This is a very niche corner case type, but there's a deconstruct method on it, which suggests we expect usability of this to be paramount.
It makes it much easier to make the generated code use tuple deconstruction than it is to manually assign it to another local and then pull out the properties.
Okay.
So I put it on there just for simplicity of generating the code.
Okay.
And then it makes it easier to represent some other concepts a little bit clearer in C# syntax by being able to use tuple deconstruction. And just less locals to track.
In the source generator.
In the source generator, yeah.
So one question I have is like the namespace is relatively new, right? Marshalling.
Yes, we introduced this last release for all of the less commonly used, like all of the library import related types, except for library import itself, I think.
And is this containing types that we expect users to use from their code, or is this generally plumbing that we expect to effectively only be used by the source generator?
This namespace generally contains more advanced types for the user to use to customize the attribute for the source generator. So it's types that generally are used in more advanced use cases.
But they are used on the user side that then triggers effectively the source generator. So in that sense, it's part of the user used API surface, right?
Yes, like for example, when we introduced the bster string marshaller to have built-in support for bsters, if you want to manually use that through marshal using, or I'm trying to think, there's a few others that we have that are like that.
Sorry, I missed that.
Yeah, there's
the marshaller types in system runtime interop services marshalling can be used through marshal using by the user to handle let's say like marshalling an array of strings as an array of bsters. You'd have to manually specify the name. So it's for more advanced use cases, but it's types the user can and is directed to use.
It's entirely, I guess it's a reasonable argument to make that something like virtual method table info could be in its own other namespace. They call it, interop services infrastructure or something like that, that is not necessarily intended to be directly used, other than if you are building your own source generator or building up an entire system. There are levels here of utility. Marshalling does have all the marshalers. So yes, users will see them in some cases. For example, this isn't a great example, but I think Beaster, I don't know if we actually respect the higher level notion of Beaster.
That was the reason we brought it in boxes to represent the higher level notion, but that still only works for limited scenarios.
The point is, there are cases where you may not necessarily want to use it, but there are cases where the users can. They are exceedingly niche. So I don't know if this rises to the level of more, a deeper namespace that is even more niche.
Yeah, that's fine. I think I'm just trying to understand effectively what we intend the namespace to be used for, right? Because you create quite a bit of API surface here. So if most of what you're adding here is considered kind of plumbing for the generator rather than what the user is actually consuming, it might be worthwhile splitting apart, right? But if you expect that to be kind of intermingled anyway, then it might be better to have them all in one namespace.
So there is sorry, go ahead.
I was just going to say, at the same time, we're already 4 levels deep in a niche namespace that most people will not be using and that is explicitly documented as unsafe. So it's not like putting these types in here is going to make this unbrowsable or unreadable, particularly not in addition to the unmanaged interrupt code they're already going to be writing and dealing with. So my own vote would be, let's not look at isolating these specific things even further, just keep them in marshalling.
Yeah, I like Steven's alternative proposal in the comments of just put it all in system.
For everyone watching and listening, not a real proposal.
Yeah, obviously. I just wanted to let you know you got a good chuckle out of me on that one. Yeah, so looking at system runtime interrupt services marshaling, it looks like in there right now, we have basically, it's all the custom marshalers and all the attributes that let you define new marshalers and associate a marshaler with its different use case.
Yeah.
So if we wanted to, we could have like a system runtime interrupt services virtual methods, I don't know, or something like a sibling namespace to marshalling, so that marshalling stays only having marshaler stuff, and then we have one that has the COM related things.
No, I mean, that's the thing I wouldn't do, right? So Tanner's point is like if you try to break it like that, then because these things are also tied at the hip anyway, like you end up in this world where you can't quite tell which namespace something should go into anymore. I think to me, the only interesting split would be, as I said, like if it's just plumbing versus what people actually type, there's some benefit of splitting that so that their intelligence is more limited. So when they're trying to figure out what to put on their side, they're presented with fewer choices, right? But if that again is a very fluid relationship, then I agree with Tanner. It makes more sense to dump it all in one namespace. I mean, currently you have like what, 10, 15 types in there. So you add another 10, 15 types to that, that's fine, right? That's not the end of the world. It's just that, as we know with interrupt, it's kind of like a magnet, right? The more you put, the more it pulls, and eventually you get to 100 types, right? So that's why I was kind of asking whether there is a sensible split based on use rather than based on area.
We could move the types that the user would most likely type themselves up to system runtime interrupt services. So that like it would be system runtime interrupt services generated COM interface attribute or system runtime interrupt services COM object instead of system runtime interrupt services marshalling for those cases, and then having all of the more advanced types visible when you're just using the entry attributes.
Yeah, I guess I think I said this last time. I think that would be sensible. I think if the existing ones would be very well curated, which I wouldn't go that far and claim that interrupt services is a curated namespace, but I also feel like there is value if you say like there's this new way to do interrupt, which is source generation, to keep that stuff kind of separate so that you don't confuse people by mixing the runtime marshalling with the design time generated marshalling, right? So I don't think moving things to interrupt services would be beneficial. I think the only thing that would be beneficial is, you know, some sort of split between the plumbing versus what the user types for the generator, right? And so like in that sense, it would either be a sibling to marshalling or like a nested namespace, but I think it kind of depends on what you have today, right? And it currently does seem a bit like you're blending them both in one namespace, which is also fine. I think that's
Well,
Well,
there's
the
also
examples library import attribute is in system runtime interop services, and that's the entry attribute that'll be the most common use case for people using library import. So that's why I was mentioning moving up the entry types.
I see.
there's also the perspective that library import is one aspect of the interop story. It's the perspective of this is the way users are supposed to do kind of the built-in marshalling moving forward. However, there is still CS Win32, which is its own source generator, which is going to have to duplicate most of this logic because source generators can't depend on each other, which makes it easier for users to do Win32 interop in particular without having to redeclare all the types and everything themselves. They get everything kind of implicitly through a smaller text-driven subset. They specify the method, and then that automatically goes in, pulls down, and generates the transitive list of types, enums, and everything else you need. And then there's also like the Clang Sharp side, which is it's not a source generator at all. It's I know I'm generating a interop specific library where everything is done ahead of time. Or you're doing a more complex interop story like Vulkan, for example, where you want to stay up to date with the headers over time. And that one is going to end up having an option for doing library import compatible signatures for users who want marshalling and non-blittable signatures, but it's still another case of there's going to end up being some use cases for all of those to use these other types that the generator's using itself as well.
So let me try to understand what the point is you're trying to make. You're basically saying splitting that into generated and non-generated doesn't make sense because it depends on the use?
Right, because the generator is not the only one that's going to be using the generator types. Other generators outside of the one we're providing will also end up using them to some extent.
Yeah, we're building the infrastructure
That's a fair
generally in a decent enough manner that people can put together the pieces in their own way and be able to reuse a lot of the types. We have a lot of this one's a little bit more locked down in library import, but as we get through API review, we'll see if we want to change that or not.
Yeah, I think that answers my question then. So we can just keep walking? So this guy is basically just a data holder.
Yeah.
And then this is basically the thing that gives it to you, given from a runtime representation of
or
a
from whatever the representation is of a runtime call, of the new world of the runtime callable wrapper. So like a com objects type, or well, like if we have like a, let's say this was also meant to conceptually work for like vtables as a generic concept. So like you have like a wrapper around a pointer to a JNI instance, or like the Java native interaction API.
Right.
Like a wrapper around an instance pointer for MS Quick, because that also is just a table of virtual functions. That sort of concept. It represents that it's implemented by types that represent those concepts. So that way it's part of the communication between here's the object that has this pointer and here's how to actually call things on it.
So one question I have is like, presumably we don't return anything as unmanaged virtual method table provider, right? We probably return everything as object, right? So people would have to cast that to this interface to call the method usually, right?
Well, when this interface is getting, like the caller is generally generated code in an IDIC, dynamic interface castable implementation scenario. So this type is the type of the interface. So yes, you'll have to cast to this type to get to the method. in 99% of scenarios.
I see. So yeah, I guess my question is like, why is it not just a static method? I guess that given an object gives you back the table info. But you're kind of saying that because you want to actually intercept that, so you want an interface that people can do something useful with.
So we need the type because we need to know for what this pointer in table do we need to get. So we need to pass the type in. And if we do a static that just takes an object, either it needs to be just a static and we don't know what type.
Well, it would be a static that
that
takes
static lit.
I mean, if you would make it a static, I would assume it has two parameters, right? The object plus the type.
But it was would this be just a static class that owns it? And in that case, it would have to know every possible way, given every object type, to get the underlying V table for that type. So it breaks the encapsulation a little bit.
I see.
Because each thing would have a slightly different mechanism. Like things that don't need to worry about like any concept of casting at an unmanaged layer don't have to. All they have is like a this pointer field, and they return that and the dereference of that to get the V table.
Right.
Should there be a overload of the method that takes a generic T? That way it plays better with trimming, and users aren't encouraged to do object.getType or other things that don't work as well due to the reflection.
So we thought about that, but by doing a generic, it doesn't actually save us much because doing a generic doesn't save us that much, and it actually ends up costing a lot because generic virtual method dispatch is very expensive. So we could have a public generic that just calls a protected virtual non-generic, but that's kind of weird.
Right, I was actually suggesting that we have a get virtual method table for key T, and its implementation is literally just call the non-generic version with type of T, because that's what we've done with the activator APIs and the other marshalling APIs, specifically because that pattern works with trimming better.
Would we want to have the non-generic one public, or would we want to make it protected on the interface?
I think we'd still want it public because that's how we've done the other cases. Users sometimes need or want to support a scenario where they don't know the type ahead of time. But we should generally encourage people to use the generic one when it's available.
I'm still stuck on the users of this though. Like everything you said, Tanner, makes sense when you're talking about very mainstream things. But if I understood correctly, we're talking about types here that I can count the number of users on one hand plus a couple of source generators, and we'd expect them to always sort of do the right thing. Does the generic, I mean, the generic adds complexity based on what we're talking about. Does it really earn its weight?
Well, I don't think it adds complexity. It's two lines. It adds potential.
It adds another member to the interface.
Right.
That's complex.
Which people don't need to implement.
Sure. But
this whole thing has so many dims in it anyway.
Like I'm not seeing the complexity of having having an overload that users don't have to implement. It's just a convenience thing for them to call that helps push them towards the right thing.
But that's the thing. The complexity is just anything we add is more stuff, and we keep saying users, but who are the users? No one. I mean, so few people use this thing. They're going to have to follow very strong documentation about how to do it. I guess I just don't see the benefit.
I mean, it seems to me like because it's an interface, like it's already like this. I don't think you can have like, even protected members, right? So
you can with dims, you can,
but only when you make them a dim, right? If you don't make them a dim, then I don't think you can, right?
Yeah. No, you can have a non-dim protected member. I had that in a previous design.
Okay.
I actually had the generic. I had the generic constrained through some mechanism to kind of abstract away the concept of the type. beforehand, but we got rid of it because it didn't actually work for the COM scenario, which was the first actual battle test of the API.
Is adding this generic method post a breaking change in any way, shape, or form?
There's always the risk of the diamond problem, but I wouldn't expect someone to do that. There's also the option, of course, do it as an extension method. Then it's not a member of the interface, but rather just an accessible API.
Is the diamond problem still a case if we make it sealed on the interface?
You
Can you? Is that a thing in interfaces?
You can.
so
I had
so
that before. I had the generic sealed and the non-generic virtual abstract.
so if it's
Fascinating.
non-virtual, then I don't think you can hit the diamond problem for it.
I mean, to Steven's point though, right? I mean, we are now kind of like deep in the weeds of like to maybe help some minor usability issue, right? Which
Well,
I
it's
mean-
not necessarily just usability. It's also a level of correctness in terms of if you want to support AOT scenarios, particularly where reflection and dynamic code gen aren't supported or available, then you want to explicitly be avoiding patterns where you end up with reflection.
But
Yeah.
we're talking about the difference between saying open angle bracket T, close angle bracket, and open paren type of T, close paren. Those are equally trimmable and equally understandable by tooling.
Right. The difference is when someone comes in and does object.getType.
Sure, but who is that person? Like again, if this wasn't
I have
17 levels
seen-
deep in namespaces,
So regardless of this being 17 levels deep, I have seen so much bad interop code out there because people just don't understand the right processor pattern. Even with the built-in marshalling, even with everything else, you know, it's a niche scenario that still has millions of users where they get it wrong. Like the number one site people go to for pinvokes, pinvoke.net, is like 99% bad examples of pinvoke that often don't even work.
and that's fine, but we're not talking about pinvokes here. We're talking about system.interop.marshalling.whatever, unmanaged virtual method table provider. Like that will never have millions of users. If it does, we're doing something wrong.
I mean, people go and write. There's at least 10 different competing DirectX interop bindings out there.
And the whole purpose of this COM source generator is to drive that down to not be 10.
Yeah, but that's not going to happen.
Well,
There's
we
still
shouldn't
going to
invest
be
in the
10.
features. Like if this isn't going to replace people using their own stuff, then we shouldn't be doing it.
No. There's still going to be 10 competing implementations. Some of them will use this, and some of them will not. And that doesn't
the folks
negate
that
the
choose
fact
not to are because they really think they know what they're doing and they can do it better. And whether we provide a generic overload or not, like having to write, type of T instead of .get type is the least of their problems.
I'll just leave it up to. I think we have very differing opinions in what is, difference in overhead and complexity in the exposed API surface.
I think that's probably fair. I think it's always degrees, right? And I think to a large extent it depends on how much weight somebody applies to the gain versus the cost, right? I think the interesting question I think is like, as a matter of principle, I think also is like how hard is it to add these things later, right? If the answer is probably it's easy to add later, I think it's fine to say we can wait for feedback. If it's super difficult to do later, then we probably should make up our own mind. I mean, I will say like gut feel wise, I kind of agree with Steven that it does seem like a little bit on the, the clever API side, right? Which always comes down causing some confusion and cost, right? But it also, I mean, there certainly is a kind of trend in .NET code to prefer generics over types, right? Just for aesthetic reasons. So I think a lot of people would expect it to be there maybe. but I think it's a I don't feel as strongly, I think, as Tanner, in the sense that we must have it.
Yeah, my view isn't even necessarily that we must have it. It's just that this is a best practice that we follow for all of our main APIs. And this is another scenario where that best practice fits, even if it's a niche API. And so we shouldn't be inconsistent with our own rules, and we should just do the right thing here. The
To your point, I think we have different definitions of what do the right thing is.
As for the diamond problem with a sealed dim, I don't think you would get the runtime diamond problem, which is ambiguous slot and your assembly fails to load, but you would still be subject to a source breaking change of two different interfaces have defined different methods with the same name, and now you'd have to do a typed call into that method to invoke it. So there are still diamonds. They're just
Okay.
fewer if it's sealed.
So for reference, like if it weren't for the overhead of a generic virtual method dispatch, I would have done generics. But we're trying to eke out perf here in this design and make sure that we don't back ourselves into a corner where this isn't performant enough to move from the built-in COM system. So I wanted to avoid the obvious overhead of generic virtual methods.
Yeah. So it sounds like we're leaning towards not then, right? Is that fair?
We can always come back and add it as an extension method.
I think extension method would be the easiest to reason about for sure.
Just to confirm, from my own understanding, whatever implements this needs to support it for multiple types. Is that a correct statement? Like you wouldn't, what would happen if you moved the generic up to the interface level?
Basically, like the type parameter here is to support the concept of casting. So like for COM, the type represents another COM interface, so you can do a query interface. If you're wrapping an object that doesn't have a concept of casting, then you're always going to get the same type passed down. So you don't even have to check it.
So logically, it's only relevant for types that implement more than one interface, right?
Yeah, for objects that implement more than one interface and have a way to get from one to the other.
Which I guess in COM there's always going to be at least two, right? I unknown and then whatever else you actually implement, right?
Yeah, but people won't be asking for I unknown through this, I don't think, because I unknown is going to be handled by the runtime.
Well, so query interface isn't just interfaces that the type implements. It's also essentially a conversion. For example, in DirectX, you can, from the graphics device, query the factory. The factory is effectively a property of the device. It's the thing that created the device, but the device does not in fact implement the factory. But query interface allows you to query and get that regardless. So it's not just about what do I implement. It's quite a bit more complex than that.
I mean, that's basic COM aggregation, right? Where you basically delegate it to somewhere, right?
Yeah.
Which comes with its own fun rules around IANO.
Once again, DirectX doing weird stuff with COM.
Oh, DirectX isn't the only one that does it.
Yeah,
they're the worst offender, though. I think we could all agree on that. The only the distilled nature of this is, we needed a projection of query interface in something that makes sense in managed code. So I need to project my interface through some type, and I need to know how to use that in the native world. That's really all this is.
Yeah, and at this level, basically, through this, like this type and the next type, the first three types are the infrastructure types that are designed to be not COM specific. They're meant to work with just the concept of like unmanaged interface types that have virtual, or unmanaged types that have virtual tables of virtual functions.
Yeah, I think that was my other question. So I think everything we have is kind of tied to the notion of COM, versus this is just any ABI standard that basically has the concept of vtables would use this, right?
And if you notice, we could which we didn't want to intentionally, that type as an input, that could easily be a GUID. If you change that to a GUID, that's actually what's going on here. But the notion of GUID is very much tied to this is how the IUnknown system works.
Right.
And that's not necessarily appropriate for every notion of virtual method tables. Like who knows what your key is? It could be a string because you hate yourself, as opposed to a GUID. And so the notion of we want to just say the managed idea here is a type. However you interpret that type to map to a V table is the mapping. That's all this really comes down to.
Yeah, like for example, Swift. If we wanted to reuse these types for Swift interop, because they have the protocol tables that are effectively V tables, we wouldn't want to have to come up with GUID types or GUIDs for every single type in Swift.
Makes sense. I mean, yeah, I think I understand now what you're going for here. And that's probably a lie, but so what is this one here then? Unmanaged interface type?
So this type would be implemented in the COM source generator by the generator on your attributed interface, and it gives you it will handle allocating once and laying out correctly the V table for a CCW to use, a COM callable wrapper of an object. So when you get like an IUnknown pointer for a managed object through COM wrappers, it would be able, like when setting up the V tables, it could grab this as one of them to represent the type that implements this interface.
Let me try and give you a different perspective on that. This is for projecting the managed object into native code. And we need that managed object to say, you're going to be passed down into native code. You're going to be passed down to some other subsystem. Give me the V table so that I can, for that system, that can call back to the managed side. And that's the void star. That void star represents what is the table of functions that I can use in Swift and COM and whatever other world to get back at the managed code.
We already have a well-defined layout for what that V table looks like to the native world.
That will be the contract for the source generator. So for COM, yes, right? For COM, we all can agree that there is a well-defined layout. And so when unmanaged interface type is used by the COM source generator, it knows how to construct its V table. And the idea that was brought up here was Swift generator, that's going to have a very different layout for its function table, virtual table. And so the Swift source generator would generate a very different implementation of iManage interface type for a managed type to be projected into the Swift world. And as you can see, it's a static because if a type exists in managed code, it is projected in the same way to the other side, regardless of instance. Does that make sense?
Yeah, I'm trying to understand who actually consumes this and what they do with the void star.
This is handled by that transition layer from you're about to marshal this managed object, this managed notion, down into the unmanaged world. And so this is, as Jeremy pointed out, this is implemented by the source generator and filled out. And when we are passing down through the marshaling layer, marshaling a managed type down to the other subsystem, the unmanaged world, we will say, give me the ABI function pointer layout that I need to pass down so that that unmanaged world can use it.
But what I'm missing, and I probably just I'm not understanding, the source generator is providing the implementation of this property, right? Isn't it also generating the marshaling code that consumes this property to pass it down?
Part of it is to help make this trim safe, and by putting it on the interface type in a way we'll be able to get to from the interface. then we can make it such that we don't immediately root every single interface that could possibly be used by the user. We would only root the ones that the user actually uses.
I guess.
And there's
I'll
also the
process that.
possibility of using trim safe reflection to be able to discover the interfaces and getting at the implementation instead of having the source generator generate out all the instances. So for example, if you have a COM object that gets, if you have a managed type that implements 3 COM interfaces, 2 from this assembly and 1 from another one, then your COM callable pointer will be able to have all 3, because we can't have the source generator looking at every single generated COM interface type in all of the assemblies transitively referenced by the current compilation, because that is absurdly expensive and will completely kill performance.
Let me try and parrot what I think I heard back. If all you cared about was making this functional, there would be nothing wrong with the source generator just spitting out its own internal class with a whole bunch of property 1, property 2, property 3, which it both generates and then generates the consumption of. There's no need for that reason for this to be defined by the type itself via a static virtual on an interface. The reason you're defining it as a static virtual on an interface is because and even for trimming, it shouldn't matter, because a static, like you wouldn't be rooting everything and doing so. The trimmer would still see whether things were used or not and would still get rid of it. The reason you want to define it on the interface is because you actually want it to persist in the binary of the type that implements that interface, such that another assembly consuming it will be able to use the same generated table. Is that the reason?
Yeah.
I think that's a really good way of putting it. Does that resonate with you, Steve? Or is there?
I understand if that's the goal. I understand why we want this. If that wasn't a goal, I don't understand why we would promote this to this level.
The other idea was to provide a contract for, like, a name for everyone to use. Was the other idea. So that
the thing that I don't understand, though, about that being the goal is if I have 2 different source generators, the Swift generator and the COM generator, each one of those is going to want to provide a different implementation for this method.
That's a fair criticism. That's absolutely fair. You're right.
Which kind of breaks this model, right?
It does. If you're saying can a type that basically with this model, you're right. A type can only project one one representation into the unmanaged world of itself. That is fair criticism.
There's also the fact that we've never seen an example of a type that you'd want to project one way into COM and another way into Swift from managed code. We've never had that sort of concept before. And we haven't found any examples of APIs where, like, the same type is usable from 2 systems without one of them being the quote unquote true implementation of the ABI of the contract and another just being a projection of it into another world.
I think that's fair push. I think that Steve's point is very, very valid.
Yes,
there
is also very valid.
There is that is a limitation of this design. There is only one way to project it using whatever, like, there's only one way to project it using this interface. Yes.
Yeah. We used to have a concept of, like, you have a generic on ion managed interface type, and then we use that as, like, the identifier for the type. But we found that did not actually work in practice to get us the information that was needed.
Well, I think it's less that. It would be more like you need a way to differentiate Swift from COM from winner T from whatever else there is, right?
Yeah. Like, we could have, like, ion managed virtual method table provider and ion managed interface type both be generic on something and then use that as part of the contract. And whatever type you put in there identifies your type system world, like the COM model or the Swift model. But I don't know if that's...
I mean, is this an actual problem? I mean, assume most user types wouldn't have to project across multiple runtimes, right? But I mean, there are some shared things where it would make sense, right? Like core types, like not string, right? But something to that extent that you want to exchange would make sense to project to multiple technologies, right? So what we tell those people, like have different types.
The idea, I think maybe you could probably construct a contrived example where you had the .NET runtime loaded in a process that was communicating through some sort of COM interface on one hand and the Java runtime in the same process on the other. I think the push, and that would all be in one process, and that would completely fall apart at this point. I think the counter to that is doing everything in proc. We've been slowly moving away from that model and doing more. If you would like to do complex interop with the Java runtime or some of these other runtimes, you should do it at a process boundary in a lot of cases. That's not always practical for performance reasons or otherwise, but I think if we got into that case, that's probably the pushback that's probably the suggestion that I would have made. I can see a world where there's a .NET process communicating through on a native side with COM and a parallel loaded JVM in the same process. I can actually see that as being a thing.
And would use the same type as the same contract.
Yeah, and it would use the same type as the same contract. But that's, I think, the point of this type is so that we can be reused.
Okay, I think this is not the problem where I don't have a mental model anymore. I think what is happening, like, is the idea that the implementation of these interfaces will be generated, or is these something that the user, so basically if I have my type foo that I want to project to, let's say both, you know, Swift and let's say Java, right? I would have one assembly that would basically do the source generation for Java, presumably, but I have a different assembly that would do the source generation for the marshaller for Swift, and they both happen to be based around my foo type, but then the generated type would be different, right? There would be a Swift foo and there would be a I think a Java foo, whatever my other example was, right? and I think that, so I guess in that world it would be fine, right? Because it would be kind of, because there's different implementations of that interface, you never have, like, the source generator is implicitly encapsulated effectively by the generated object rather than by that contract, right? So given an unmanaged interface type, you wouldn't be able to tell which side this is for, right? It would be implicitly, well, if you call to the Swift side, only give me the Swift implementation of this interface, don't give me the Java one, and if you do, well, then bad things are going to happen, right?
So related to the concept of publishing one of these things, so I've got a public interface in my assembly, and I've used the COM source generator to fill in all of this gook on my interface, my public interface. I then consume it in some application that is also using the COM source generator to pass this object to some COM function. What guarantees at the consumption side, where I'm passing this to the COM method, what guarantees that this type's implementation was done with the COM generator rather than a different generator? I'm not talking about two generators at the same time with the same interface. I'm talking more about, I've implemented this whole thing with one. I published my library out, and then I try and someone else is saying, "Oh, I'm going to pass this along my COM boundary." Like, is there an analyzer that somehow recognizes that it was implemented incorrectly? It was implemented with the wrong generator, and so it's not compatible, or what does that look like?
Yeah, that is a good point. It might be worth it to roll this interface into the next interface, which is the interface that represents specifically a COM interface, because it adds on the concept of an interface ID. So then we could have this portion be COM specific and then revisit how we'd want to represent this for each generator that we introduce.
I agree. I think that would actually solve a bunch of these very sticky problems that I think you're bringing up, Steve.
Yeah, I think that might be the right decision. Is
Maybe
this interface used to serve a lot more purposes in this model, but it has slowly lost them, and I don't think it needs to live on.
I think that addresses the things that I was raising, although maybe it would make sense for us to keep going, and then you guys can revise it and we can just discuss the changes or something.
I mean, it would literally just be take the ion manage interface type, that function on there, and plop it onto ion known interface type.
I see.
The type right below, yeah.
And so, because that's the only thing it's inheriting from, right? And that way, it's very much now it's no longer the problem that you're talking about. It's like this is an ion known interface type. The ion known ABI is well defined, regardless of how many source generators exist. That is what it needs to look like, and that gets to, I think, Emo's point, which is we have an ion known interface type. The extension there would be iSwift interface type.
And so, but when we cross that boundary over to ion known, we are talking specifically about COM now, right?
Yes. As soon what ion managed interface type is the last non-com specific type in this proposal.
And should we be changing namespace at that point too?
I mean, that's my other question, generally, like how do you tell them apart? Is the idea that there's other types in this namespace for Swift, or would we have an attribute that says this is a Swift generator, this is a Java generator?
If you look at the rest of them,
the rest of them are all very clearly named, like ion known and com in the names.
And so you would imagine,
like these guys.
I don't. Yeah, like everything, as Jeremy pointed out, everything below the ion known, I think
the ion known interface type and below is very barring some implementations of some of the interfaces where we can hash out naming. Everything has ion known or com in the name.
Right. Yeah. Those are those first three are the only four things. Were the only thing that are kind of generic.
Yeah, and then the next issue that we probably won't get to has all of the rest of the more generic concepts that can be used by the COM generator, but we can also avoid using manually and just emit directly in the generator if we don't want to approve the APIs.
Nice. So some open questions, and I've sufficiently derailed us, so we can keep going.
That was a good question.
I don't think so. I think it was
a very good question, and it helped us. We ended up designing into this corner, and you pointed out a lot of the issues that we were going to hit.
Yeah, I guess my more general question is when you look at these kind of objects, is this kind of a uniform way to identify which technology they are for, or is it just you look at the other implemented interfaces and then because it's ion on something or ICOM something, you just know it's COM, and Swift may have an iSwift something or whatever, right? But there's no generic way to say, oh yeah, this is COM, this is Swift, this is Java.
So there will be the attribute the user puts on the interface to trigger the generator, which we will leave on.
Gotcha.
I think for all scenarios, and there's some other attributes that we end up having to emit onto types that are mentioned below to allow us to have trim-safe implementations of iDynamic interface castable.
And then the other question I have is all this COM stuff, does that make sense on a non-Windows machine?
Yes, COM wrappers works on non-Windows. It works on everything except for mono. And one of the biggest reasons to create these APIs is actually to move a few customers of ours that use an older technology for enabling COM style APIs on non-Windows to be able to move onto this and off of the existing tool.
Gotcha.
That whole project is why this is prize 0 for us.
So then I guess COM would be the only inbox implementation of that ABI, and then Swift would be something that would sit on top, Java would sit on top, and whatever else, right?
Yeah. With possibly some infrastructure types that we have to get approved, but the source generators themselves would be owned by like the Xamarin iOS Mac team or the Xamarin Android team for Swift and Java, respectively. Okay, so do we want to go on into the more COM interfaces?
You mean the truly controversial part of this review?
Yes. So we have the unknown interface type that represents that this type is an interface that represents an unmanaged unknown based interface, and it would have the member from the interface above and the IID. Then this interface would be implemented automatically by the generator on the user's type.
Are we spelling IID like this normally?
Do we have spellings for let's look at some.
Unknown, yeah. There's a few on Marshall.
Yeah, usually we're doing like our IID because in the native APIs it's a reference to a GUID that's passed in.
Oh,
yeah.
sorry.
So if we look at Marshall.query interface, there's the second parameter is a GUID named IID for representing this exact concept.
Yeah, and the Marshall as attribute from Net Framework 2.0 has an IID parameter index, which is big I, little d.
I mean, I just read it as lid. I'm sorry.
We can name it interface ID. If we want to be more wordy, we can name it interface ID.
Well, I was more thinking like, because we do the same thing for RSA and SHA, right? Where we basically just used all uppercase letters, even though we wouldn't, right? So I was just wondering whether IID was one of those things that we did that, or whether we actually used the Pascal case convention. If we already do, then I would just keep using it. If we don't, then I would match whatever we have done, because it's probably more readable than capital I, lowercase ID.
Yeah, Marshall as attribute has the IID parameter index with the same sort of capitalization, but this would be the first one that is just IID. That's a property, or something that we would Pascal case. Every other IID that's just IID is a parameter.
Yeah, it's not a biggie given that everything else here is probably not exactly pretty, but interface ID might be slightly easier to read.
Oh, yeah, that's just me being, this is what I call it. It can really be anything you want. It doesn't matter to me.
Yeah, I don't feel super strongly. I was just, as I said, I just read it as lit, and I was wondering what a lit is.
Everyone
It's
who's
of all caps.
who's familiar with COM is going to know what IID is.
Oh, I know what an IID is. It's just normally when you read it, it's like all caps, right? To me, it's just the particular spelling that is throwing me off. Or casing, I should say. But yeah, I don't feel strong. Seems like everybody else is fine with that. So let's leave it as is.
Okay, so then the unknown derived details interface is a base interface to help us have a contract to go through our attribute route and allow the users to provide their own mechanism for, given a type, get information like what is the IID for the interface, what is the interface type that provides the DIM implementations of the interface, and what's the pointer that we can use to pass down as a vtable for this type.
So why is this an interface and not just a struct holding those things?
Because it needs to be implemented by an attribute
So if you look
immediately below. And this just provides a non-generic contract that we can call.
Gotcha.
And then we use generics combined with static abstracts on an attribute to give us a trim safe mechanism to look up the attribute.
this particular pattern was suggested by the trimmer team because it works for them. So agreed. When I first saw it, I was not happy, but it does actually make their lives very easy. And I don't want to use the word elegant because I wouldn't call anything in that unknown derived attribute elegant, but it is very helpful for trimming, and it does express it very precisely.
It is more elegant than any other option we have tried.
That's fair.
Sorry, I'm kind of like when you say the attempt. So what is the thing you need here? I mean, like either you go via the attribute, or what's the other strategy?
If the user wants to like hard code situations for their cases, if they wanted to like, there's some situations that aren't technically correct for COM, but also would work, and users who want to eke out every last little bit of performance might decide to do, like the Tanners of the world, or Tanner.
So I guess what I'm saying is, so you have a method somewhere that accepts an unknown derived details, and user pass in either the attribute or they pass in their own instance of it. Is that the idea? Like, I guess what I'm struggling with is like why you need an interface to unify them.
Yeah, and then you also like we need the interface so we can call the members on it, because we don't have the unknown derived attribute. The attribute type we don't have is a reified generic. We're able to ask for, we need the unknown, we need attributes of type of unknown derived attribute, comma, just the open generic, and then we get the object, and then we need an interface to call these members on.
So what you're saying is you have a method that takes a T that is constrained to unknown derived details?
I just put a link to the example in the chat.
And then, and then I think it's in the default strategy implementations. It's the where is it? The get unknown derived details. If you go on the right, it's the fourth interface option. This is where you can see how we do the lookup.
So where do I click?
Can you click on the stuff on the symbols side?
Yeah, which one should you want me to click on?
Get unknown derived details. So this is how we get it, is we have a runtime type handle, and then you get back the details object. So to do this without using, like having to use make generic type and having to use reflection, we have an interface so we can easily access the members.
So to maybe give this something that isn't necessarily obvious. If I have a type, there's the infamous, if I have a C, like system.type, there's the .GUID on there, that property.
Right.
Calling that is not trim safe. That uses reflection under the covers.
Right.
And there's no way to detect when it goes down that path.
So we need to basically say, how do I get rid of this? And in order to do that, we can use, if you look at the implementation of that, the very first thing that I sent you, right there. So there's that very specific get custom attribute. Like that is, that's reflection, that's a problem. That is true, but it's also trim safe in that pattern. And so we are doing something that what would be considered, this is reflection, this is a problem. That's true, it is, but it's well-defined reflection that is supported by the trimmer, and we can get a specific type off of the attribute that has the information that we need that is statically defined, that we know for certain will not that will not trigger a ton of runtime machinery like the .GUID property will.
So the way I solve this in TerraFX is static abstracts. I have an interface iNative GUID, which has a static abstract native GUID property. Anything that declares itself as IUnknown whatever can additionally implement this, and then you can get a reflection free and allocation free in the case you're using RVA constants GUID.
Now, how do you do that with iDynamic interface castable where you don't statically have a bound generic for your target type?
Right, you would end up having to take in an additional T, specifying which T you want to get the GUID off of. It would still be, so it would just still be generics, but provided you take in the generic parameter as an actual generic, then you can keep it reflection free.
We're limited by the contract of iDynamic interface castable, where we only get a runtime type handle.
Okay.
We did go down static abstracts at one point, Tanner. It did hit some issues, particularly around what Jeremy's saying, because of the complete unknown nature of we don't know what you're going to cast to.
Mm-hmm.
And yeah, if we had implemented IDIC as generics, then we'd have a generic to work with, but we didn't. We did it with runtime type handle because that's how the implementation was kind of designed initially, and also probably more efficient, just given that it's generic virtuals. Again,
is there an API we could expose that allows you to get it beyond, that allows you to get the GUID in a reflection free way? Like native AOT currently doesn't, but .NET Native did recognize .GUID and bake it in as a RVA constant. So there's potential options there on ensuring that the quote unquote right thing happens and that it is no longer reflection free.
Yeah, I think that's fair. I think this particular pattern lends itself to other things that aren't GUID.
Okay, yeah,
We could definitely go down the path. I think you're right. I think there probably are things we could play with. I will say that this pattern, because of the way it's designed and my understanding of how it works, it's built into the language. It's a very new language feature, and it allows us to say, I don't want GUID anymore. I want choose it.
I want the combination of a GUID, a type, and a pointer.
Sure.
Which is as our example, at least, because we need the type to return from IDIC. We need the void star for when we're constructing the wrapper object. And then we need the GUID because it's common.
And so the next one, the interface, this is what Jeremy was referring to, the IUnknown derived attribute. This is what will tell us that the interface, the IFU is it's basically, this is more or less what com import kind of currently does.
Yeah, just built into the runtime with a lot of goo.
So this gives us that, it gives us the things that we need to tie it all together. And this attribute is what you could really map almost directly to library import. And so the argument could be made, and I wouldn't have any pushback of this might want to be at the same level as library import, or we could hide it in marshalling, or we could put it in some other namespace. But this is that entry point that I think might actually make sense to go someplace else.
Well, this isn't quite the entry point. This is one that the source generator emits still.
Thought this was
no, because we generate the implementation interface too. So this one we emit on every interface, but it's not the one that you.
Oh, it's the generated com interface. Sorry, I'm sorry. I got ahead of myself.
Yeah, but this is still like, this is the kind of the linchpin interface and attribute that the whole system works with.
Sorry.
So I think that makes sense. I think I'm still not entirely sure why you need an interface, why it can't be a struct, but I guess I take your word for it at this point.
Well, it can't. So the interface needs there so that the attribute
can't implement it.
Well, but I mean, what I don't understand is like, why can't you just call a method on the attribute that gives you back the struct? I guess because it seems like your transport is the thing that that is
we need a non-generic. We need a non-generic type to call a method on to get the struct.
Oh, because I see what you're saying. Because you want basically say you want somebody else to define their own attributes. You don't care about what the attribute is.
Well, no, because the attribute, it's unknown derived attribute of t and t-impl. We have a runtime type handle for t. And the whole point, one of the reasons of going to the attribute is to be able to get that implementation field, which is just type of t-impl. So we can never fully construct the type of for this attribute that we pass to get custom attributes. So we can't even statically write it because we don't even have t. We have a runtime type handle for t. So we need some non-generic type.
I see. And I think now I got it. Okay. Yeah, this is not vanilla. This is a this requires some amount of mental gymnastics.
Yeah, so Rumpus, these APIs will be available for just .NET 8 also. It's not just .NET 8 Windows. This will be available everywhere because COM wrappers is supported everywhere.
Yeah. Okay, that makes sense now. I think now I'll review again.
So now we get into the strategy interfaces. The ideas between each of these interfaces is to allow the user to customize how the COM object behaves so that we don't have to provide a one size fits all and you have to pay for what anyone might ever want to use COM object as exists in the current built-in system. Basically, like today for COM, the built-in COM system has to support, really it's thread affinity is the big thing. It's supporting thread affinity in every possible manifestation on any version of the OS any version of Windows we can run on. And there's a lot of complexity there that everyone has to pay for, even if your COM object does not care about thread affinity.
This particular interface is just as niche as the virtual table thing.
Yeah, basically this is, how do I do IUnknown? Because there's a few different ways. You can either just, if you don't care about threads, just do IUnknown on the object. If you want to use the concept of an IIGL reference to be able to easily, without having to worry and use a simple API to query interface for the current thread, you can use IIGL interface to implement this interface. If you wanted to wrap it around a weak reference for whatever reason, you could use iWeak reference resolve as your query interface call.
So this doesn't encapsulate COM as much as it just encapsulates the interaction model that COM has, right?
Yeah, this encapsulates the concept of query interface and release, basically.
And you could, if you're curious, add ref could be on there, but the reason I didn't, or I don't think is it doesn't necessarily need it. It's kind of what Steve was getting at. Just adding a function for completeness may not necessarily be most appropriate. The reason being, by the time at this point you get your IUnknown for in whatever manner is, you could almost assuredly call add ref because you're on the appropriate thread if someone's giving you a COM object already. The release in the query interface may not necessarily be true.
Yeah, the idea is basically like you have your ref in your object, and you don't need to call an additional add ref because it's given to you, and you own the ref when it's handed to you, and then you only add the references when you call query interface, and then basically it's QI and then release. There's no need to have additional calls to add ref. So we didn't provide it.
So you're basically saying query interface would be the way that already gives, basically does both query interface and add ref for you effectively.
It gives you
Yeah.
back an owning IUnknown or an IUnknown interface. So it's guaranteed to have the add ref performed.
Yeah, and that's just by design in COM. So all the ways that you would implement this interface using any existing COM concept would already handle the add ref.
So you're saying in COM I also wouldn't call add ref after QI?
You could, but you're given back an add ref when you QI.
Well, I mean, you say you could, but then isn't that a memory leak if I call it too many
Yes.
times? Like,
Yes, well, yes, you could call, but you'd have to call another release.
Right. Yeah. Sure. Yeah. As long. I mean, what I'm saying is that basically, normally you just call QI and release, and so if you call an add ref and release, you just added a memory leak.
Yeah, especially in the .NET world where we have the GC and we have an object that can get passed around that holds the reference. We don't need to manually call add ref like every time you save it to a field.
Right. So is then the idea that unknown strategy really then means effectively do COM stuff with this infrastructure, and there would be like an iSwift strategy at some point, or an iJava strategy, or I guess iJNI probably.
That's a pattern.
Yeah.
But at this point, we've already bought into the IUnknown world, so maybe there is no strategy necessary on those others. I don't know enough about the contracts to make an intelligent statement there, but this is, we are potentially establishing a pattern here that we may want to mimic, but I don't know if it's appropriate.
Yeah, I think it depends on the target system. If that model has multiple different decent ways of doing something, that we'd want to allow people to do one thing or the other. Whereas like if COM didn't have a concept of thread affinity and it was just add ref release all over the place, then we wouldn't have this because we wouldn't have to care about it. There's multiple ways to like query an interface.
So I guess unknown interface detail strategy is the thing that gives you that basically was the thing we looked at earlier, right? The getting the attribute, casting it to the interface, and then calling it, right?
Yeah, the next interface is that, yeah, the IUnknown detail strategy. The screen is still showing IUnknown strategy. At least
Oh, sorry,
for
I was scrolling on the wrong window.
Yeah, so IUnknown interface detail strategy is just get the details through the attribute or however else you want to from the runtime type handle.
So why is it a runtime type handle here and not just type?
Because we had a runtime type handle in the place we needed to call it, so we just put that there. We can change it to a system type because you can get a system type from a runtime type handle.
I think it's not always necessary to have a full type at that moment. There are some calls here. Oh, there are calls here where we query, I believe. And there's no reason to create one if we don't need it. And as Jeremy pointed out, we can create it quickly, but we can create it quickly and from basically any type handle, but doing it preemptively is unnecessary.
Fair enough.
So we're just passing along the existing information. Here it is. If you need a type, yes, you can do that, but we don't necessarily want to perform that allocation if we don't need to.
And then if I have a type, how do I get the runtime type handle? Just .type handle or whatever it is?
Something like that.
I believe so.
Or
There's
like that handle or something.
Yeah,
It's just a property on it.
there's something to go back.
But most callers to this, or at least the callers that we provide internally, or the ones that we'll write internally, will already have the runtime type handle.
All right, then.
So I have a dumb, very low level question. We're adding a bunch of interfaces here. How many of them need to be implemented by users versus how many of them are being implemented by the generator? Because if it's mostly the generator, do we need the interfaces or can we just faith call?
So what? So most of them are going to be implemented by the generator, and we just need contracts. These strategy ones will have default implementations that provide decent experiences for most mainline modern scenarios, but users can implement their own versions and use them.
Because with
But
the
will
other
be
marshalling
a
things we did,
TypeScript for the generator.
yeah, some of the other marshalling things we did, we just faith called. Right? We set up, here's the pattern, it's going to write a call to this, or if you have this, it will call it. So I'm just, given that we, super massive hand waving, have the general rule that interfaces are bad, we seem to be adding an awful lot of them. And so it's,
Yeah.
I'm just asking, do we need them?
So for at least some of them, we only, like, we don't have a type that we can statically call on as part of it. Like we, like this object, this variable doesn't have something that's typed such that we can just do static calls easily. Or we'd have to put on another attribute and say, go look at this thing. Or we'd have to make another, or we have to make an assumption somewhere. Other ones, it's just like in, like beforehand where we just called things by faith, it relied on us writing a ton of analyzers and code fixes to make sure that the system was all valid and internally consistent. And we did it because we didn't have the type system tools to do what we needed to do in the time frame we needed to do it. Was a big part of it.
Okay, I mean, yeah, I don't personally care that we talk about super, like, okay, we really need this one, we could cut this one if we, I'm just asking, is the big, like, are the interfaces needed? And apparently they're at least needed in some cases for, literally there would be nothing to faith call because you need a, var can only do things if they exist. And especially if you need to reach further forward, that's a reason for an interface, unless a base class would be suitable. But it sounds like on many of these, it's the base class couldn't do anything. So an interface is all you're going to get. So, all right, that's continue.
Yeah, so then here we have the IUnknown cache strategy. This provides the caching for query interface results and putting together different pieces of, like, given a query interface result and the IUnknown interface details for the interface, here's where we cache it, so that we don't have to do the lookup multiple times because QIs can be expensive. The built-in system has a very complex cache that handles all the different scenarios we could ever possibly need, which a lot of people might not need all of them. So we wanted to provide a strategy mechanism so that you could have something a little bit more tailored to your scenario, where you could remove some overhead if you don't need the feature. Once again, thread affinity being the main thing.
And you use the struct rather than out parameters for extensibility, or?
I think just because that's, I don't think we had a reason of why we did.
Sorry, which one?
Table info. I think
Oh,
properties because we felt like doing it that way.
as opposed to giving out like 3 parameters instead of just 1.
Yeah, I mean, it kind of depends on how. Like, if you want to add a 4th one, right? Struct is clearly easier, right? But 3 is within the realm of, like, maybe parameters would still work, right? When it's 4 or 5, like, I would probably no longer do it.
Yeah,
I think the part.
the philosophy that I've always gone with, if the struct is going to be bigger than 2 pointer sizes, make it a struct. That's just how I normally do it. But if you think 3 parameters is reasonable, then I don't have pushback.
Yeah.
Unless Jeremy does.
Construct table info would get really ugly of having 3 out parameters or returning 2 out parameters. Is my only concern. And we can't use tuples here because pointers.
Oh.
Yeah, I mean, it's generally not as convenient. I mean, keep in mind the way these things tend to work is like, unless you are in the interface, right, you now have to say unknown cache strategy dot table info, right? So it's not going to be pretty.
Yeah, I think all of our use cases were using var.
I think so.
You monsters.
var is best. Use it every var.
Yeah, I'm not going to defend like the people that like explicit types everywhere. No, it's just like whenever you have a nested type, like it's, when you construct it, you kind of have to know where it's coming from, unless you're doing it directly as the argument, in which case type inference might work for you, right? But it's
we could make it at the same level. I just nested it, I think, purely because of it's associated with this. I agree with you.
The number of colors of this, though, is going to be
less than 5 in the world.
Aaron, Tanner, and Steve's going to do something for a perf blog post, and then he'll try and purge it from his memory. And so everyone who's ever going to use this is on this call. And
Sergio's pretty.
Steven, did you say you promised yourself you're not gonna?
Not going to cover unknown cache strategy. Yes, I promise. I'm making that declaration now.
Yeah,
no
so
offense.
While we generally don't like nested types, I don't. We're so below my caring threshold personally.
I would just say for Stevens.NET 8 blog post.
That you never have to name the type unless you're like writing an implementation. So even in usage, you wouldn't have to name it.
Yeah, I guess that's what I'm saying. Like, it depends on where you put it, right? Like the downside of nested types is usually if people have to put it in signatures or they have to new it up, it's not intuitive when it's a nested type, but it's kind of like environment special folder, right? Where if you have to qualify the enum, now you have this super ugly double nested thing going, right?
That's what using static is for, because then you can just special folder dot.
Yeah, but if I have just one call
drop
site, I'm not gonna
too.
scroll up all the way to the top of the file to just add that one thing and then scroll all the way back down to wherever it just was and then add the call, right? But yeah, I'm fine. I think making it a top level type is clearly not necessarily better in your case here because it's a super narrow type. I think the only alternative realistically is just more parameters, but yeah, 3 is definitely getting into the area where it's getting ugly.
Yeah, I guess if we wanted to make it top level, it could be unknown cache table entry.
Yeah, and then unknown is great as a struct name too because it sounds like an interface.
Yeah.
So like, yeah, I guess we leave it as is because it seems like all other options are ugly in a different way. I guess I have to scroll in the other window, right? Otherwise, you don't benefit from this.
So this com object is for everybody involved. The replacement, the replacement in the source generator for __ com object. That is its purpose.
So this is the thing I would see in the debugger. Is that what you're saying, or is that the thing that would actually? Yeah.
You would see this in the debugger, and for one use case that we'll get to later, you would actually like have an instance of this you can do stuff with, mostly for that final release scenario.
There's 5 things on here, only one of which is directly useful by the user,
and even that's only sometimes.
And all the rest of them are implemented by us. They're implementation details. This is sealed. This is just a type that they'll view.
So
The IDIC are implemented on there for the dynamic casting. That's what they're for.
right.
Finalizers, we have to implement that because of lifetime rules. This is again just like what underscore com object does. The final release is that infamous Marshall dot final release com object. I'm not sure if anybody's familiar with that API, but it is the worst API in the world.
But there are use cases for it that are very few and far between, but they exist and they are very hard to work around when you can't have that option.
Is it basically calling release in a loop until it reaches 0?
Or just it's clearing out the whole cache and then releasing everything.
Ouchie,
What's the reason for exposing it as an iDisposable here? We expect that syntactically people are gonna call final release, putting it in a using block, do something, and then
The only way to use so the problem with the built-in system is our internal caching. How we do internal caching and how it gets cleaned up, particularly with thread affinity, there's just a myriad of very complex reasons that the final release is just messed up.
It gets in, you can get in very bad states where in the middle of a final release you have something that tries to use the object and then it crashes horribly.
So why expose it then? It sounds like you're basically arguing for never to use it.
I agree. In the built-in system, you can absolutely use it. You get into weird cases, but there are cases, and we can debate whether they are valid or not for sure. The point of this is in COM wrappers, it was intentionally designed to say you can do a final release. It's completely legitimate doing final release, but there are a sequence of constraints that you need to accept. And one of them is you can only do a final release on a COM object in COM wrappers if you say this is a unique instance. And what that means is you control its lifetime. You are permitted to control the lifetime, and we do not put it inside our cache. And so if you don't call final release, that's fine. The GC will clean it up. It'll absolutely clean it up. That's not what that means. What it means is it is not a cached instance. So you can never, there's no way to get at that particular managed projection of a native object if you lose reference to it.
So basically by cache you mean we basically take the native pointer and use it as the key. So if you ask for the projection again, given the same native pointer, we would give you back the same object. And you're saying if you want to be able to call final release, we won't do that for you. You have to just keep track of that yourself.
Correct.
Yeah, and then we have when we get farther down to the generated COM wrappers type below, we have a helper function that is specifically create a unique object for this COM instance, and then you get back an instance of COM object so that you can do using on the final release property.
Okay, so and that is the intended. The intention is you say using open paren my COM object dot final release close paren and then braces and do stuff in there so that it's cleaned up.
The biggest case of that is well, I guess one good example is WinForms, where they have I need to use this COM object for whatever reason. They just got it returned, and they need to use it for a very narrow amount of time. They only need it for that amount of time, and then they can get rid of it. Now, in the current system, what normally happens is they do all of this, they put it in a finally and say, final release COM object, I don't need it. That's fine, but that doesn't really clean out the cache. It doesn't do all these other things. That has to be handled later on. And in this case, we're saying, no. If you have a narrow use case of a COM object, you can immediately clean up everything as fast as possible. This has the most striking problem that I've seen with this is in Visual Studio, and they have tons of infrastructure around this, around PDB locking, because one of the implementations of DIA, and I don't know if this is still the case, locked the PDB on disk. And the only way to do it was to free the COM object. And if you didn't do a final release, the debugger locked the PDB until the CLR decided to clear out all the RCWs. It was a huge mess. And so the pattern of I want to release this COM object right now. I don't want it around. Don't wait is very common. And so COM wrappers, one of the intentions was let's make a pattern that is intentional so people can actually do this in a way that is prescriptive and not just call some random final release and maybe it'll work.
Yeah. And
What happens?
There's some
Sorry.
teams even in non-Windows that, or not in DevDiv, like over in the Windows org that I know have hit this issue, and they're specifically asking me like, what do I do here? And I'm like, final release, like there's no other good option. Like this is the only way that you're going to get this to do the thing you want it to do.
What happens if you
Because-
use the
yeah.
COM object, the instance after you dispose, and what happens if you dispose it multiple times?
You mean in the final release thing? Like if you call it and then use it?
If I get my COM object, the thing that's on the screen, and I say dot final release dot dispose, if I do that twice, or if I say dot final release dot dispose and then I continue using COM object, do I AV? Like what happens?
Object exposed exception is probably what we do.
Yeah. Is what's going to happen.
Okay. So something meaningful.
Oh yeah, absolutely.
Yeah, we will make it nice and not crash the runtime.
Okay. And
And-
what's the reason, you may have said this and I missed it, but what's the reason for having it be a final release property rather than having COM object just implement iDisposable?
So if we look in the WinRT world, which over future iterations may be able to reuse this system, like we may eventually unseal COM object to make that work. I don't know. Future discussion to be TBD. In WinRT, the iClosable interface is projected to iDisposable in .NET. So there's already the idea of like you can have a COM object that's iDisposable, but when you dispose it, you don't actually call release and release all the COM pointers. When you call dispose, you're just calling the close method on iClosable.
I see.
And there's also another case which I find if you were to implement iDisposable on COM object, my concern is we would literally just proliferate usings on every COM object. And that's only appropriate if you use unique instance.
So how common is it though? Like if it's very rare, like do we really need to expose it as an iDisposable rather than just void final release, open close paren, and then just call it if you need to, don't call it otherwise?
You'd have to do everyone have to manually write a try finally, which is just
that
preferable to not is really all that it is.
sure. But
Like,
if
for
we
the
expect
cases you
this to
wanna
be
do
like
it,
6 people,
please make it
then
nice.
maybe that's
Sorry,
okay.
go ahead, Emo.
I mean, if it's very rare, I think try finally is not that bad, right? It just depends on, like, to Steven's point, is like it's a bit weird to expose it as an iDisposable if you don't pass it around, if you just use it for this one narrow case. I mean, I guess it works, but it does feel a bit like it's not a pattern we usually have where properties are iDisposable as iDisposable with the intention to just put a using block around some arbitrary property of a type. It's not really.
So
I think the thing that's striking me as strange, and if at the end of the day we decide this is what we want, fine. I don't have any huge concerns, but it strikes me as a little strange that we've exposed an iDisposable that is a separate object, so it sort of logically has a separate lifetime.
Right.
Whereas if it's you have an object and you call a method on it, whether that's dispose or final release, you're doing it on that object. Whereas here you can kind of pull off this iDisposable thing and it's totally separate from the COM object, and then you get this spooky action at a distance when you dispose this other thing, and they don't have reference equality or any way to check that these two objects are related.
Sure.
So I don't know.
That's
That's valid.
fair. The reason, the kind of the idea behind it is it's nullable. So it's only going to return it if it can be disposed. And so if we just have a function on there that's final release void, whatever, in any case, I can always call it. Like, no, you can't always call it. I wanted an indication to say, this can be final release. You have an option here. But if you get null, you can't do it. It's
Doesn't
very,
that, I mean, I'm trying to imagine what the consumption looks like. If I'm getting back an arbitrary COM object we're talking about I always call final release because I don't know whether it's relevant or not, or I write 3 lines of code that's, store I disposable D equals final release if D does not equal null D dot final release, or with some nice syntax with using, or with a null coalescing operator, or whatever. But it's not like, if I know in advance whether it's going to be null or not, then I know in advance whether to call final release or not. If I don't know in advance whether it's going to be null or not, then I'm actually writing more code to do the check than if I just call the method.
Yeah, the method should just handle the null, because the using statement in C#, if it gets null, it doesn't call dispose. So the equivalent would be you write try finally, call final release, paren, it's void. It does nothing if it isn't a unique instance. It does nothing if it's already been called on this unique instance, and it does something if it's a unique instance and it's the first call.
Sure.
And people who really want to use using statements will make a iDisposable wrapper for com object that indispose forwards to final release, and that's fine.
I mean, we can always call final release like create lifetime services, right? That totally works. Sorry, that's a bad remoting joke. We don't want to go there. So then I guess we do what now? We make it a method?
Void returning method.
Yeah, that will no op if it's
Doesn't do anything yet.
it'll do nothing if it's not allowed to release. I think it's the best way to do it. Because otherwise you have to expose a way to check, can I do this? And
which there'd be basically no point, because you're going to have that same check inside. So
yeah,
I assume that also means that you would not throw object disposed, you would throw invalid operation exception or something to that extent, but I would probably still maintain the idempotency of I guess that's not the right terminology, but basically make the second call a no op too, right?
Yeah.
Because with dispose, it should be the case that calling it multiple times is safe.
Yeah.
And the first one took care of it. And I would do the same with final release. Granted, the documentation should say once final release has been called, the object is in a, like, don't ever do anything at all, because good God, what's it going to do? But we should still make it as safe as we can.
Is there the only benefit I saw from, well, I won't say that there's one piece of functionality that having this as returning an iDisposable question mark provided, and that is, as in the remarks, like, it allows you to tell whether it was created with unique instance or not. Is that piece of information important? Like, does that need to be exposed in some other way on com object? Like, what flags were used to create this com object? I don't know if there's any reason that's useful.
I mean, other than the fact that if you decide to share it throughout your system and you want to make that check, I think it's just one of those ideas to say I don't have to call final release.
I mean, like, we could always expose a, is unique instance, or, int com create flags, or, whatever answers make sense. We can return that piece of data to people, but we still shouldn't say that the method throws if you didn't check it ahead of time.
Right. No, I agree. I'm wondering if, in addition, like, separate from the whole final release discussion, if there's additional information we should be surfacing on com object. I don't know the answer.
I don't think so right as of now.
I mean, I think that there might be a case in WinRT, but I would have to defer to Jeremy if he has an idea, if that's useful.
I think for WinRT, the main thing would be like it not being sealed and being able to derive from it, but that's something to revisit after discussing with the CS1RT team, if they want to move over and how they would want to move over, because I think they might want to do it slightly differently, such that keeping this sealed is still the right decision.
Then I would change. Yeah, we can change it to the method, and then we can revisit if retaining the flags for creation is appropriate. It seems like a reasonable place to start. We can add that in the future if necessary.
So next up is the trigger attribute finally, the generated COM interface attribute.
One moment, Jeremy and Aaron, there's chat was going back and forth about availability in Windows. You did say earlier that all of this actually does do something on .NET on Linux, right?
Yes.
Okay, so it's not Windows only. It does work in places. Things do things. It's only mono that it doesn't work, which is what I thought. But
the COM wrappers API was enabled for all platforms in, I think, 6.
I think it's all platforms in 6, native AOT in 7.
Yeah.
Mono still doesn't have it, but also, so I guess like we can say not on .NET on iOS and Android and WASM, I guess.
Yeah, but it does stuff.
It works
which is not what
cross-platform.
the chat
COM wrappers
says,
works
so.
cross-platform, yes.
Well, because with
All
the external native AOT support for iOS, then I guess it does work there.
All right, thank you.
So when you say it doesn't work in mono, do you mean the AOT runtime or do you mean like mono? The whole enchilada?
Anything that uses mono just doesn't have COM wrapper support yet.
I guess what I'm confused by, I think of mono as the old .NET cross-platform implementation, but there's also mono as in the native runtime that we use on iPhones, right? So that's why I was kind of asking, like, which flavor of mono do you talk about? Because to me, the latter is kind of like, yeah, that one makes sense, but the former, we don't add APIs to mono anyway, so I don't know why we would.
So mono VM, the mono implementation that lives in .NET runtime that can be run on a ton of platforms, but is only officially used on iOS, Android, and WebAssembly.
And that one does not support these things, you're saying?
It does not support COM wrappers.
Yeah, okay, then I got it. And we have no plan of enabling that because it also doesn't make sense, I suppose?
Just the platforms that we care about the most for this, we have support for. If someone in the community wants to do it, we'll definitely support it. We don't have time.
Yeah, that's what I thought. Okay. All right, so this is the attribute that you put on.
Yeah, you put that on your interface. You point the generic points at the COM wrappers type to use as to like specify as like this type's COM wrappers. And this is for like if we wanted to hard code the vtable entry. So we basically say like this COM wrapper supports like creating a COM object for these 3 COM interfaces. So now as the design has changed, it might be worth it for us to just have like a COM interface attribute that's just the attribute.
So is the idea that the user basically has to say public partial blah, or do you generate that type entirely based on what the person put in the attributes in the angle brackets?
They would have to do public partial blah for the COM wrappers type. But an alternative option, as we were talking about, I don't know if we want to make the decision right now of constructing like what vtables to pass down via reflection so we can support the cross assembly scenario we talked about earlier with Steven earlier on this call. For let's say 3 COM interfaces, 2 defined in another assembly implemented by an object. Do we want it passing it through a COM wrapper to have all 3?
Gosh, I don't know. That's a complicated question.
Yeah. We've been having and hawing on that portion of the design for a while.
So I think I didn't quite understand the question. Like, I mean, you put this attribute on an interface, right? So can you have multiple interfaces pointing to the same T-COM wrapper?
Yes. And you can have an interface, and you'll be able to have an interface point to multiple different COM wrappers by having, actually, no, each interface would only point to 1 based on how we have this defined. Yeah. But you can have multiple point to the same COM wrappers instance or COM wrappers type.
And that would make sense when? Like if I know that they're always co-implemented anyway, so I want to just treat them as one logical .NET object?
So it'd be for when you create a wrapper through COM wrappers, that it would always check for those interfaces. So you know that it's like, for this COM wrappers instance, I'm going to run all of my DirectX all my
I see.
DX12 interfaces through it, and this other one I'm going to run all my DXGI types through it, and this other one I'm going to run WMI, and this other one I'm going to run WinRT Goo through it.
Sure.
Let me see if I can find the initial design doc that explained why we went this route. I
And
think it
then-
was because we were thinking of we were planning initially at the time doing zero reflection support at all and hard coding everything.
So what is the thing about vtables across assembly boundaries? Like, why would that require reflection?
Because you have to do git interface on the type, or git interfaces on the type of the object to figure out what interfaces the object implements, so that you can correctly grab all of the interfaces that the object implements that have like the IUnknown derived details attribute on it.
Yeah, but why can't you do this statically? I mean, the source generator runs in the Roslyn compilation context where you can resolve all the things and you can see whatever they have, right?
It is extremely expensive to go looking through every single type in the compilation, including reference types from other assemblies, to find all types that have an attribute on it. Doing it for all types in source with a given attribute is cheap, or cheap enough to do. But to look through every single type in every single assembly that a compilation references is horrifically expensive, and Roslyn will chase us down and yell at us.
I guess I don't understand, like, what's the limitation? You're saying I mean, you put the attribute on something that exists in source, clearly.
But then if you, let's say I have an object foo that implements COM interface A, B, and C.
Right.
COM interfaces A and B are defined in assembly A, but my COM object type foo and COM interface type C are implemented in assembly B. And when building B, I reference A.
Right.
I have that foo object. I want to pass it through a COM wrap. I want to pass it through the generated COM wrappers implementation object. Like, I want to pass it through COM wrappers. Do I want it so that if I pass it through the COM wrappers type in assembly B, I only get ICOM interface C, and then if I pass it through a COM wrappers in assembly A, I get ICOM interface A and B for the COM object for that coming out of that COM wrappers instance. Or when going through either of them, do I want to have interfaces A, B, and C?
And what are you doing today?
And so this particular portion, we haven't made a decision. We've been putting it off.
I see.
In our design, when we were talking about let's avoid doing all reflection, we were going to hard code it and had considered whether or not to do either option and had yet to make a decision.
But I mean, it's like kind of what I'm confused by is you don't have to do the reverse lookup, right? I mean, if you start with an interface, you can find all its base interfaces statically, right? And that's cheap, right? And then you can see whether any of them have attributes that point to a type, and if they don't, you get to decide whether you want to generate one or not, right?
Well, you don't have like a fully derived interface. You'd have to look at all callers to COM wrappers, to the COM wrappers get or create, COM instance for object, and then figure out the type of the object that's passed in, and then look at all interfaces that object implements.
Okay, that one I don't think I can. I mean, yes, if that's what you do, that is expensive. Like any reverse lookup would be expensive. I just don't quite understand why you do the reverse lookup. But that's fine.
The previous idea was that we would hard code the interfaces based on any interface that has the attribute in the current source assembly. We would generate support in the COM wrappers.
Right.
But there was also the option of doing it via reflection and grabbing things that also work across assemblies.
And presumably you don't know whether cross assembly is a key problem or not.
Yeah, because we we can't even find them because we don't necessarily know that anything implements them, because
Right.
it doesn't help that com wrappers type all the methods on a take object.
But in reflection, that would equally be expensive because you would basically have to do a reverse lookup there as well, right? So if it's expensive at design time, it's going to be even more expensive at runtime, right? So it sounds like it would be a non-starter there as well.
Yeah, the built-in system for reference effectively uses reflection in the runtime to look through all the implemented interfaces and find common interfaces to project.
But what assemblies are you looking at? All the ones that happen to be loaded, or are you going on disk, find all the assemblies that are there, and then enumerate them all? Like, I mean, the problem there isn't so much they use reflection, right? The problem is that you have to look at every single type in the universe, right?
Well, if you're doing it with reflection, you have the object you're going to pass down at the time that you're doing reflection. So you can do object.getType.
Oh, I see
And
what
it's
you're
whatever
saying.
interfaces have been preserved, which is not the best unless we
Sure.
annotate com wrappers with trimming attributes.
I see what you're
All
saying.
interfaces.
Yeah.
Which also, like, a ton of implementations need that anyway. Like WinRT is going to use that. Anyone who's going to use reflection is going to want that. And you're going to want to keep all the interfaces anyway, because some of them might only be used from unmanaged code. If you're passing an object down.
Makes sense.
So that might be something worth doing anyway.
All right, I think, like, should we put a stop here and then resume next time?
Yeah.
Sure.
Because it seems like our velocity would be another hour if you want to finish this.
Yeah. If we skip the com wrapper base type, the rest of them are basically default implementations of the three strategies.
But we have definitely lost quorum.
Yeah.
Yeah.
Let's do that next time. Hopefully it's quick, and then we can loop this in with the other API proposal, right?
Yeah.
I will be. We're gonna have about 5 minutes on the other proposal, and y'all are gonna be like, "Nope, we should defer."
Why?
That's gonna happen. Oh, it's in the weeds, man.
It's a lot.
It's in the weeds.
So let's put it this way: the proposal we went over today is the high-level proposal. This next one is the low-level proposal for when you want, basically, that if we really wanted to, we could just build the system on top of, and internally, it effectively is built on top of in the implementation.
Sorry,
It's
that
all
was
about
we looked at the high level stuff today. That did not seem like the high level stuff.
Yeah,
The high level stuff is
really-
what we currently have. The one that uses reflection and underscore com object. That's the high level stuff.
relatively speaking. So I think the other one, to be honest, I think between what Steve said and kind of what I'm feeling from y'all, we could. It's not required. It doesn't have to be public. We could wait for a customer to actually ask for it, and it is not dependent on any of our existing goals for this work. It's just, here's a bunch of APIs that build up and we use to implement this. It's all about making them public so that people can further extend and manipulate. And
yeah, a lot of them we might just have the generator emit as file scoped types to make our lives easier.
All right, so then, okay, then maybe we should just schedule another half an hour maybe to finish this, because that sounds like we should be quicker on this one, and then maybe we can take a look at the other one and then give you that read on that.
Yeah.
sure.
Sounds good. Then let's do that. Thanks everyone.
Before we drop MO, going to bring up the thing I brought up, I think 2 weeks ago on we're slowly building up a increasingly larger backlog again because we're getting through 1 to 2 issues a week, and we're in the part of the dev cycle where we're getting at
Yes.
least 3 or 4 new issues per week.
I agree. Like I just got pinged yesterday again on 2 other issues. So yeah, I'll set up another round on Thursdays. This week I can't do it because this week we do a community stand-up, but maybe Jeremy could host. Would Thursday work, Jeremy?
I can host. I don't know how many people are involved in your Thursday. If we're gonna have quorum, especially with
No, it's
shorter
community
notice.
stand-up, right? It's just me and Bill basically talking to
Okay.
the community, right? So it's on YouTube, so anybody can watch it afterwards, right? But in terms of liveness, it's only like 2 of us who are gone, so it should
Fair
not
enough.
remove the quorum.
I mean, Jeremy, Aaron, are you guys available?
We have
Thursday?
the
I mean, if
town hall, but we can leave that early if we have to.
I was gonna say, if not, we'll just skip your issue and get back to it on the
No,
Tuesday
this
after.
is
So
this is a priority.
This is a high enough priority. We can skip a town hall,
sure. So
or at least leave early.
I mean, the town was
Yeah,
also supposed to
I mean-
end. We can just book it for 90 minutes. That also works, right? So we don't have to. 90 minutes is better than 0 minutes, right? So
yeah, so yeah, I'm available to chair, so it'll be fine. And
Sounds good.
yeah, I think YouTube chat got broken at some point because I tried putting the text correction that says that we do work on non-Windows, but I tried twice and it failed. So
yeah, sometimes
YouTube chat seems to be broken.
it's weird. All right, thanks everyone, and then I see you Thursday / next week.
Thursday. Okay, sounds good.
Bye bye.
Bye.